Awesome. Perfect. So again, welcome everybody. So we're going to be talking about scalable SQL and Python ML pipelines. This is a key area that enables organizations to take their ML experiments into production. And so in this talk today, we're going to be I'm going to be talking about operationalizing challenges in ML. And so it's really about everybody can train a model. It's the difficult part is what comes before training a model and then after. And then this talk we're going to be focusing on the before part. What's really important in the before part is having production grade machine learning data pipelines that can feed your training processes and inference of models, and that's really key for taking data science experiments into production. So we'll talk about that. Then we'll move over and talk about how we at Snowflake view data preparation for machine learning, feature engineering, data engineering, how our newly released capability of Snowpark, which lets you define all this logic in Python um, rather than SQL, comes into play. So we'll learn a little bit about that. And then we'll talk about Scikit-Learn as an example of how you can leverage Scikit-Learn within Snowflake and Snowpark to implement some of these feature engineering techniques and also do machine learning model training and inference as well. And finally, you'll see that in action today. I don't have a lot of time, so we'll jump into it. It won't be a long demo. It'll be a very quick demo, just as a quick example of what you can do and how you can operationalize stuff in Snowflake. And so when we talk to organizations, the ones that are really reaping the benefits of their investments in AI and machine learning are the ones that are doing this at scale, that have perhaps thousands of models in production. Almost all their business decisions are being, aided by decisions made by AI and ML systems, be it, automated decisions or hybrid that are in conjunction with humans. But they are, all of them that are really reaping the benefits are running AI at scale. However, what we see is most organizations are not reaping the benefits, and they're running into challenges. And one of those challenges, one of the biggest challenges that we see is taking an idea, an experiment, an ML experiment that data scientists might be running in their notebooks and putting that into production. And so that's the key challenge that we see. Typical ML workflow, you see these two iterative cycles of experimentation and production. The data scientist will start with the experimentation, and then once they find some insights and the experiment is successful, then they you know hand over the baton to data engineers and ML engineers that help them put these models into production. And for most organizations that are struggling with this, what ends up happening is that these two cycles are really happening in two different environments. And it might be that those environments are totally separate for data, and a lot of times they're separate for compute processing as well. And so data scientists might be leveraging one compute service and might be leveraging an extracted CSV for their experimentation. And then the production teams might be leveraging a totally different uh, single source of truth or data warehouse or data lake, and a totally different compute and infrastructure for deploying models into production. And what that leads to is this is where organizations get stuck. This is why this handoff from experimentation to production is so challenging, because you have different environments that the team are working in. Not only are the teams different, but they're working in different environments as well. And this is not just us saying. You can see, this is a study that was done by Forrester back in 2020. And the key piece there is 14%, and I don't think it's changed that much. I would still venture to guess that it's less than 20% of organizations have a repeatable and a defined process of going from machine learning experiment to a to a model deployed in production that can then serve a downstream machine learning enabled application. Um, and so how are we thinking about this problem at Snowflake? And so this is the key question at Snowflake, because we believe data is the most important ingredient for AI and ML workloads. And we view Snowflake as a solid data foundation to enable mature data science machine learning practices. And how we do that is by letting our customers develop a single source of truth of their data in Snowflake. And so that's where we got started as a cloud data warehouse. But now with the evolution of Snowflake into a data platform, it's not just a data repository, it's not just running reports on your data, but letting you bring in all sorts of data. So, you know, structured, semi-structured, unstructured data, and not only having your first party data, but very easily subscribing to third party data sets through our marketplace operations. And then once you have access to this data, be able to process that data, whether it's for data preparation, feature engineering, data engineering, but also for model training and inference, and defining inference pipelines in Snowflake as well. And doing all of that while giving you the best in class experience in terms of security and governance, giving the right access to to the right people in timely fashion is another one of those challenges with machine learning that's not talked about. And so think of us as a solid data foundation and a processing platform that can really enable um, your machine learning practice. And so our vision of how we aid our customers with machine learning is by providing a singular platform, a singular environment on which they can do both experimentation. So data scientists could leverage their favorite developer tools, be it IDEs, Jupyter, any kind of notebook environment, but be working with data sets that are, cataloged, that are best of breed, high quality data sets in Snowflake for their experimentation. And then once they're done with that, it's very easy to package up, and you'll see that in the demo today. For me, as a data scientist or even as a data engineer, to take that code and put that into production within Snowflake and within that one environment as well. Um, so that's at a very high level. Let's go and talk about machine learning pipelining. The most important thing is feature engineering, and there's a lot of terms here that overlap. And at a very high level, how we see feature engineering is we tend to bucket them in two different buckets. There are derived and calculated features, where you're doing things like grouping, sums, maxes, averages. Example could be number of items bought by a customer in the last 30 days, mean time between transactions for a user. So there's a lot. It's they tend to be compute intensive, and because they're compute intensive, we want our customers to persist them so they could be reused. And the second bucket is what we call representational transforms. And these are things like, one-hot encoding, where you're going from a categorical variable to one-hot encoded variable. And these are not really compute intensive for most ML, structured ML problems. And there you can just, instead of materializing them in your database, you can just compute them on the fly. A quick example here is, I have a users table. I calculate the time since last purchase, and from there I can calculate the average time between transactions for a particular zip code. And I have this feature that I'm then using in downstream machine learning applications, and perhaps making a catalog or making it part of my feature store. So it makes sense for me because I'm spending compute cycles. It makes sense for me to materialize this and make it available, so I'm not calculating it over and over again. And so another example of the other bucket, which is representational transforms. Again, one-hot encoding is the very common one, where I have a categorical variable. I'm going from categorical to a one-hot encoded, and this is one of those things where you can just calculate this on the fly. And how we view this and how it should be calculated is for these derived and calculated features. We encourage our customers to use our SQL and the Python APIs that are made available by our Snowpark library that can process this at scale for large scale data. And then you can persist those out to these tables, these feature tables that can then be used as feature stores. And you have one pipeline that's calculating the feature, and it's running on a certain cadence, and that feature could be used by multiple machine learning workloads on the other side. And then for representational transforms, we encourage our customers to really leverage the machine learning tools of their choice. A lot of them for structured data tend to use scikit-learn, so I'll use that as an example in the demo today, to do things like encoding and binning. And so this is really, there's a lot of gray area. You can do a lot of this stuff in Snowpark as well, but this is sort of for one-hot encoding and encoding. Use the ML library. For calculated features, you can use Snowpark. So now let me talk about Snowpark a little bit, and give you an introduction to how we are enabling additional languages in Snowflake, and how you can define these pipelines using data frames, UDFs, and stored procedures. And essentially, Snowpark is a combination of data frames, UDFs, and stored procs that lets you define all your data engineering, data science, feature engineering logic in Python against data in Snowflake. And so previously, prior to Snowpark, if you wanted to do Python programming, you had to run the Python program outside of Snowflake, host it somewhere else, and it would connect using our Snowflake connector to data, and Snowflake pull the data out of Snowflake, and then you'd process that outside of Snowflake. With Snowpark, I can run native Python, and with the use of our data frames APIs, UDFs, and stored procs, I can all run it all inside of Snowflake. I don't need an external compute service to run this. Going a little bit deeper, and I won't spend too much time here, is this is really a client server model where you have your data frames library, which is a Python library that you pip install. This is the Snowpark library that you pip install into your development environment. And the other portion is your the ability to run UDFs, so user-defined functions and stored procedures that are written in Python inside of this Snowflake compute service. And the way this works is I can define a UDF, let's say called predict, for let's say I have a pre-trained model, and I want to take that and use that inside of a SQL query or a data frame operation. And what the Snowpark client will do is it will um, pickleize or serialize this UDF and push it into the Snowflake compute environment. And once it does that, it becomes usable in a Snowflake query or a data frame operation. Any kind of data frames that you write using Snowpark, the Snowpark client will eventually transpile that down to a SQL query, and it is the SQL query that ends up running in a distributed fashion on Snowflake. And so here's a quick example. I have all these cells, and I have a UDF. I can take that UDF and push it down to the Snowflake, and then I can use that predict UDF in my data frame operation, and it will lazily evaluate that and produce a SQL statement in the end that runs. But as a data scientist, you're doing this processing, and you're writing all this logic in Python, and you don't have to write it in SQL at all. And so I can write native Python functions, push them down, or write uh, uh, these data frame operations that get pushed down and get executed at scale in Snowflake. And so then what I can do is automate these as pipelines. And so we provide these tasks that can execute on a schedule as new data is coming in. Your data will automatically get processed into the right kind of features, so it's made available for training as well as inference pipelines downstream that you can also define in Snowflake. Um, so I'll come back to this, but let me quickly talk about Scikit-Learn here and what I'm going to be using in the demo to implement this. So you've got these transformer objects that can transform the data, for example, one hot encoded, and then I can train an estimator which abstracts the machine learning algorithm. And then once I train these transformers and estimators, I can actually package them up in a singular pipeline object on which I can input unseen data and I can get predictions back. And this is something that I'm going to be using from Scikit-Learn inside of and packaging it up as a UDF and stored proc and pushing it down into Snowflake and running it at scale all within Snowflake. So let's see the demo. The demo is actually very simple. I've got a training data set. I'm going to be using a stored proc to run the large scale training here. And then I can save the trained model and pipeline to a stage. And for inference, what I'm going to do, if I'm going to be using a large data set, I can read the saved pipeline or the trained model into UDFs, and I can run the UDF at scale across a Snowflake cluster, and then be able to write those predictions also into a destination table in Snowflake. Um, the setting up an environment, and so for this use case, I'm going to be using VS Code, not Jupyter. You can set this up in Jupyter very easily. So setting up a Conda environment, creating the Conda environment, and simply selecting that Conda environment within VS Code. And so let's, before we jump into the demo, it's a very simple machine learning example, and you've seen this where we're trying to predict the median house value. So you've seen this probably hundreds of times before, but essentially we've got numerical features and we've got a categorical feature. And there are nulls in there, so we want to do imputations, handle nulls. We want to do some scaling of the numerical features, and then we want to do one-hot encoding for the categorical feature. And then we want to input all of that into a random forest model and package that up as a pipeline and run this all in Snowflake. Um, so let's quickly go and move over to the demo here. Give me 1 second. And in the interest of time, I know we're running short on time, so I'm not going to run this, but show you the key parts of the code here. And so, in addition to my Scikit-Learn, I'm bringing the Snowpark library, which lets me define data frame operations. And then I make some stages to save my models. And this is really where I develop my model and train my model. And so it's essentially just plain Python code. And I train my model using Scikit-Learn. I have a full pipeline where I have a preprocessor and model. I fit that, and then I write that out to a stage in Snowflake. And all I have to do to push this down and put it into production is call this stored proc utility method in Snowpark that pushes this train model function down in Snowflake. And then now I have a stored procedure that I can just schedule inside of Snowflake or schedule using Airflow or my favorite orchestrator tool out there. And then once I have this, I can run this on a cadence. And and as new data comes in, I've defined a UDF that can take that new data and run that model against that model. And so here I'm doing the predictions in Snowflake where I can see the prediction and the actual value over here, and so I can run that. I can not only retrain the model on a cadence, but also as new data becomes available, I can run the machine learning pipeline in Snowflake as well. And so going back to our presentation over here, um, what I'm doing is rather than having to learn as a data scientist, having to learn ML infrastructure, just cloud infrastructure concepts such as how to use containers, more infrastructure related stuff like containers. I'm packaging up my code as UDFs and stored procs and just leveraging those building blocks in Snowflake to deploy that. Um, and this, all the third party libraries are made available through our partnership with Anaconda, and everything is happening where the data lives. And so rather than taking the data out of Snowflake and processing and doing machine learning training somewhere else, you're running everything in one system. And so and all of this can be automated to the point where as your new data is arriving, not only are you able to train your models, retrain them, but run the inference pipelines all on a schedule as well. So the code that I shared with you, I know I didn't have a lot of time to run the code, but if you want to take a picture of this, there's a whole demo out on GitHub that you can follow along. All you need is a Snowflake account and a VS Code to run this. And now I know I'm running short on time, so I'll open it up for any kind of Q&A. So, Priyal.
Awesome. That was such a great presentation, Ahmed. Thank you so much. You talked about the trends that we have seen throughout the day in other talks as well, and kind of really across the industry, that it's just not about two separate cycles of, say, labeling and model development, but kind of the harmony between the two processes.
Mm-hmm.
Um, we have a few questions that I
Mm-hmm.
would like to now take. Do you mind just going full screen, just the two of us, so that the audience is able to see you better?
Yep, absolutely.
Awesome.
Go ahead and
Um,
stop share.
Thank you so much. First question is from Andrew, and they say, how does Snowpark handle versioning of these code fragments and artifacts?
Yeah, that's a great question. So right now, the way Snowpark is structured, it gives you the processing, building blocks in Snowflake, and how you leverage the compute within Snowflake. The version control system remains the same. So if you're using, GitHub, your favorite CI/CD tools out there like Jenkins and others, you can still use those tools. And this is really, the beauty of this pattern is that if you have existing processes for CI/CD version control in your organization, you can just keep that as is. And even the development environment, we didn't want to go in and say, you need to use our hosted notebooks. You can use whatever development environment that you're used to, VS Code, IntelliJ, PyCharm, Jupyter Notebooks, everything is supported. And you can use your existing CI/CD and version control processes to keep track of this.
Got it. Yeah, that makes a lot of sense. Thank you. Um, Next question is from Roshni, and she says, how does Snowpark enable data centric ML workflows where experimentation and production can be in the same environment?
Yeah, absolutely. So this is where, the core of this is the fact that uh, your data is in one place. Snowflake becomes a single source of truth. So it's not like you're taking extracts out of the data sets. And so we have a lot of these data platform tools where you can just create copies of your production data. Your data scientists could be working and experimenting on those zero copy clones of data sets. And once they're satisfied, they can run their tests and move that over to a production environment. The big benefit comes from the fact that it's a shared uh, data set or data environment, and on top of that, your compute environment is shared as well, and it's the same compute environment that you're running for both experimentation and production. And so it's not like you're running, on a totally separate compute environment where certain libraries will not work on the production environment. It's the same environment for both data as a data repository and as also for processing.
That makes a lot of sense, and it takes so much of the overhead of like these library management processes away from the users. Thank you. And probably this will be the last question. It's
Mhm.
from Carl, and they say, does Snowpark interface with Spark, or is it distributed compute leveraged in conversion to SQL code?
It is the latter. And so it is converting to SQL. So there is a little bit, so it does not leverage Spark at all. We're not. This is built entirely from scratch at Snowflake. We've been working on this for the last 2.5 years. And so all the data frame operations that you define in Snowpark they get converted to SQL statements. However, it also lets you define these functions as UDFs and stored procs that you can write in native Python, and we have a separate uh, Python runtime in the Snowflake compute environment, and that gets parallelized as well. And so it's not as simple as that we take everything and convert it to SQL. There are bits like UDFs and stored procs that are running native Python at scale in a distributed fashion within a Snowflake cluster.
Got it. That makes so much sense. Yeah. Thank you so much for sharing, Ahmed. We could not get to all the questions today. So, what would be the best way to connect with you in case audience members have further questions?
Yeah, absolutely. Connect with me on LinkedIn. I think my speaker profile should have that. You can reach out over Twitter as well.
Perfect. Thank you so much, Ahmed. It was great having you here. We really enjoyed the talk. Thanks so much.
Thank you.